Morning to all. My topic is a modified hybrid planar antenna for cognitive radio application. My co-author is Ravindra K. Misra. He's professor in Barampur University, Odisha, and I am now working in KLF, means Kone Lakshmi Education Foundation, deemed to be university in Vijayawada. And the objective of this topic is to design a compact hybrid planar antenna for cognitive radio application. So we have to make a planar antenna. I am making here a planar antenna, and it is applied for the cognitive radio. Before we are going to know about the cognitive radio, so different type of cognitive radios are here. So one is known as spectrum interval. That is nowadays we are using mostly the spectrum interval cognitive radio, and it is also known as overlay radio. And here what happens, we have two users, let they are using like this. If this user have the cognitive radio concept, then if this user is not using this space or the spectrum, at that time this user able to use this spectrum if the cognitive radio is here. And due to that, what we are doing, we have to use we have to design one antenna, and this antenna is for the shear. So what is that requirement? So the requirement is, first we have to find out where is the spectrum scarcity. That means where is the spectrum. That means we have to now find out the spectrum, monitor the spectrum where there is a spectrum gap, and then in that gap we have to communicate the system, or we have to communicate. So for that, what to do? We are doing like this. We are given one antenna, UWB, ultra wideband antenna. Here this antenna is used for the spectrum sensing. That means here it gives a wide bandwidth. How I will tell you now. So here it is a stair taper case is there. Stair taper enhancement. It is with this paper. I have here given this paper, what is that reference, and here we are making this for the impedance matching. That means the matching between these to this. So this impedance matching we will do it in UWB monopole antenna. So here after that I am making one narrowband patch antenna. So in patch antenna it is similar to the patch antenna, in similar. So that means we are using this WP and LP. We know better. So here this is the general what is that general width, and we can calculate the length and width of a patch antenna. So we can simply use this equation to find out this length and width of the antenna. So it is a simple microstring antenna. Now how to place this? Here I am placing this one at the front side and this one also at the front side, but at the opposite side. So that means I am feeding here to the microstring antenna and feeding here to the monopole antenna. And what is my substrate? So substrate, I have taken a free substrate. That means it is easily available, 4.3, and thickness is 1.6 millimeter. It is available easily in the market, and dimension is very less. That means 40 millimeter, like that. So this dimension I have taken here. So after that I am facing this what is that S parameter, and it is known as S11 because we are assigning port 1 to the ultra wideband antenna. So here you can see it is 10 dB. So here 3.25, and here I think this is about 9 point some value, 9.75. So the bandwidth is about, what is that, 9.5 gigahertz. It is 12 point it is 12 point some value, 12.75. So here the bandwidth is about 9.5 gigahertz. So and it is used in the ultra wideband. You can see this bandwidth is 3 to 12. So that means it is in between the ultra wideband frequency. Then after that we are going for S parameter S22. What is S22? This S22 is for the patch antenna. That I have designed one patch antenna. So it gives a narrow band. You can see it is narrow band only, and this point is about 10.5. So this point is about 10.5 gigahertz. So that means here we got this bandwidth is used for WLAN band. So like that, here we got the S parameter, a narrow band S parameter. For what? For the second port. What is about the second port? The second port is yours narrowband antenna, connected to narrowband antenna. Then after that, the isolation. That means if you are using two antenna, that must be isolated. So and according to IEEE, the isolation must be below 20 dB. So here what happened? It is near about minus 18 dB, 18, 19 dB here only, and all other places you can see it is below to minus 20 dB. So it is due to the maybe some mutual fluctuation between this narrowband and the wideband antenna. We are going to decrease this after this paper. And here it is you can see it is nearly about 10.5. In that only, if there is any induction, so this will happen. So after this we are going for electric field radiation. So we know the electric field radiations are like this. You can see this electric field radiation I have taken in different frequency of alternative band. One is 4.51 GHz, one is 7.08 GHz, one is your 11.85 GHz. So here these three are I have taken from the ultra band antenna S parameter. That means the frequency where the ultra band resonating. Second one I am designing here. It is the theta value of your what is that narrowband antenna. So in the narrowband antenna, the theta value is I have taken in 10.5. So here also I have taken this one in 10.5. Now you can see the parameters are these parameters means this radiation pattern are very similar to each other. So that so if we are taking the concept, then you can see this will happen. So this is the concept now. So if you are making everyone means you can see every radiation pattern are very similar to each other. So that means it can be used for a communication and a sensing in every direction. In this in the direction what it is given in the radiation pattern. So what is the conclusion? The conclusion is we got the wide and narrowband functionality. And how to got the narrowband functionality? By our microstrip antenna. And how to wideband functionality? By our ultra-wideband antenna. And a reduced coupling effect already. Optimally we are reducing this one. But sometime in 10.5 something is there, but we will going to reduce minus 18 dB. Already it is a minus 18 dB. We will reduce that one. Then external circuit needed. So now we got only one narrowband at 10.5. But I want to change it to total 3.8 to 12.75. So what to do? We have to use one external circuit, external tuning circuit, so that it could tuning. That means we can make it a reconfigurable antenna. But it is in conference I am not given that reconfigurability here. So this much only. And reference pages are here. And thank you. If you have any question or query, you can ask us. Thank you for listening us.